Okay, in this video we're going to do chapter 10 for the final review, properties of circles. So this first problem says solve for x given that ST is tangent to the circle. Okay, if you know that it's tangent to the circle, that means that right angle got formed, and what I know is that this is the hypotenuse. So that's the hypotenuse. Here's a leg, and here's another leg. So Pythagorean theorem tells us that hypotenuse squared equals leg squared plus leg squared. The hypotenuse is going to be 9 plus x. I'm going to square that. That's going to equal x squared, which is a leg, plus the other x squared, which is the other leg, which is 21 inches. I'm going to square that as well. Okay, so this is a FOIL. I'm going to write this twice so I can easily see what I'm foiling, and I'm not tempted to just distribute that squared because that would be incorrect. So we're going to FOIL, and I have given you a practice sheet on this, but just to reiterate what's on that material, when we FOIL, we first multiply the firsts. That 9 times 9 gives me 81. So I've done the first. Now let's do the outer. That's the 9 times the x. That's going to give me a 9x. Notice the signs are coming along with them. Then I have the inner. That's going to be this 9 times this x. So that's going to be another 9x. Then I'm going to do the last, which is x times x, which is going to be x squared. That's going to equal x squared plus 21 squared, which is 441. Okay, so then what I tend to do is bring everything to the left. And I'm going to combine the 9x and the 9x. That gives me 18x. I got that here. Notice it's 18x and not 18x squared. Plus the x squared. Okay, bring over the other x squared by doing the opposite operation so that now they're negatives. Okay, now what I'm noticing is this. X squared and negative x squared are opposites. They are going to cancel. Okay, so then let's keep going. So what else am I going to do? I'm thinking that I'm going to bring the numbers to the right side. So let me do that. So I'm going to go back to my green color, and I have 18x over here, and I'm going to bring the 81, let me bring that 441 over first. It's negative on the left. I'm going to add it so it's positive on the right. I'm going to subtract the 81 because it was positive over here. It's going to be negative here. Okay, so what is 441 minus 81? So that's going to be a 0. That's going to be a 6. That's going to be 360. So 18x equals 360. Let's come over here just so I don't run into the next problem. Divide, so I have this. I have 18x equals 360. Divide both sides by 18. And we have 18 equals 20, and that is our answer. Make sure you can do this kind of problem. Okay, that foiling is important for next year, and it's important for the final. Let's move on to problem number 25. Problem number 25 says solve for x. So what you have to remember is that when you have 2 points of tangency, so here's a point of tangency, and this is a point of tangency, and these tangent segments, shall we say, are both originating from a common point outside. What happens is that this piece right here is going to equal this piece right here. Therefore, when you want to solve for x, you are able to set those 2 pieces equal. Okay? So I'm going to get it to the point where the x's are on one side and the numbers are on the other side. Subtract 2x, that's gone. Subtract 2x, that becomes x. Add 7, that's gone. Add 7, that becomes a 5, and we are done. Okay, so 5 solves that problem. Moving on to 26. Now 26 on the answer key, I said answers will vary. And that's because you have some ability to do this wherever you want to do it. As long as you're following the correct information, you can put your answers many places. So I'm going to do it. Now I may not match yours exactly, but as long as we have the same reasoning, we are good. Okay, a radius, I'm just going to put point B here, and I'm going to play connect the dots. Okay, so I have my radius. Radius is done. Diameter, I'm going to change my color. Diameter, they want it to be DC. That means I can't use A and B. So let's use D here, and then it has to go through the center. Let's put C here, and now let's connect those dots. Okay, and there you go. So that's your radius, DC. Now I want a chord. Now the chord does use the D. So let's change color again. And what if I put my F, say, over here? And I just connected those dots. That's a chord. Okay, the secant. The secant uses B. I already have a B. So I need a P, and I have to remember that a secant cuts the circle in 2 places, and it is a line, not a line segment. So I need arrowheads. Let me just move this over a little bit. There we go. Okay, that is your secant. Oops, sorry. That's your secant. Okay, and the last one is a tangent, ST. I haven't used those letters before, so I can put it wherever I want. So let's put it over here. Okay, I want to be tangent right there. It's also a line. And let me call this S, and I'm going to give this a point and make that T. And that covers it. So as I said, you can do it any other way as long as you are following the definitions of these 5 terms that are listed under 26. Okay, next thing. Solve for the given arcs and state whether they are minor, major, or semicircular. Okay, so the first thing I can do is every single one that only has, and here, my arcs didn't hold, so I'm going to just put my arc symbols there. So if you don't have it on yours, go ahead and write those in. I'm not sure why those aren't conveying. Okay, so all the ones that are just 2 letters, they have to be minor arcs. 3 letters could be major, or it could be a semicircle, so I'm kind of on hold for a second. So let's see what we have. If you have an 80-degree central angle, I have an 80-degree arc length. 130 central angle puts that at 130. Now, since this is a diameter at GP, then I have to have 180 degrees on one side of it. That's going to make this 50. So this is 50 out here. And I have to have 180 degrees on the other side of it. That's going to make this 100, because I have the 80 already. So that's 100 out here. Okay, so now I can go ahead and answer these questions. So GI, I can see is 80 degrees. PI, I can see is 100 degrees. GHP, so GHP is here. That's a semicircle. So that's a semicircle, and the endpoints of a semicircle are the endpoints of the diameter, and therefore it's 180 degrees. So that makes this, well, let's look. I'm going to change my highlighting color to green, and GIH, where does that go? GIH. So that's everything but the 130. So what I can do is I can say 360 minus the 130 that's not included gives me 230 degrees. It's a major arc, and it's 230 degrees. What else could I have done? If I didn't want to do subtraction and I prefer to do addition, I could have said 80 plus 100 plus 50. And that's going to get me 230 as well. Either way, I get the same answer. Okay? Okay, a word about minor arcs. GI, you have to go the short way because it's a minor arc with only 2 letters. If you go this way, all the way around to I, that's a major arc. And that's not what they're telling us. So when you see that it's only 2 letters, you have to go the shortest path between the 2 letters. Okay? Hopefully that's clear. All right, so we've got a couple of more questions. So let's look at this. This says, I have this sketch. Now what I'm seeing is the basis of a theorem. I know, for example, that this is a diameter. And I know that this is a chord, and I'm observing the right angle. What happens also is that this is bisected, so I have to know that. So now let's look at what they're giving us. OB is the left side, BP is the right side. Those are bisected segments, so I can set them equal, and that will let me solve for x. So 7x minus 2 equals 4x plus 4. Okay, I'm getting my x's on one side, subtract 4x, that gives me 3x. Move the numbers now, add 2, that gives me 6. Divide by 3, x will equal 3. X will equal 2. Lost my head there for a second. Okay, now they want to know the length of OP. OP is the entire piece. So OB is 7x minus 2. So OB is 7x minus 2. Use your x. That's going to give me 14 minus 2 is 12. If OB is 12, then I know BP is 12, and therefore OP is going to be 12 plus 12, or 24. So sometimes we forget to use the x back in the equation that we had when we initially found the x. Okay, so go over this, make sure that's clear, and make sure you understand the theorem implications that allowed me to make those 2 parts of the chord equal. Okay, that brings us to this. Okay, so what do I know about this? They are telling me ST equals SY, and those are segments. So that means ST equals SY. They also told me that YT is 60 degrees. Now, in this scenario, what I know is that the chords cut arcs that will also be the same length. So these 2 yellows have to equal each other. Well, in a circle, you have 360 degrees all around the arc. So the entire arc, the entire arc is 360. I have used up 60, so I have 300. That 300 has to be divided equally between the 2 yellow pieces. So take your 300 and divide by 2, and you should get 150. This has to be 150, so does this. Okay, so when they ask us to find, and here again, make the arc notation, if yours is missing. SY is 150, and ST is 150. Okay, these are chords. These are the arcs associated with chords in the same circle, and therefore they are going to cut equal size arcs. Okay, that's one of the theorems also. All right, now this is moving into 10.7. Up to this point, we have done 10.1, 10.2, 10.3. Here's a 10.7 problem. So the center of the circle is 0, 0, and a point on the circle is 4, 0. Write the standard equation of the circle. So circles are x minus h squared plus y minus k squared equals the radius squared. So look at this circle. Okay, I'm going to just sketch this circle. This center is 0, 0. And then the point 4, 0. Okay, so let's see what's going to happen there. This is the point 4, 0. That makes the radius 4. If the radius is 4, that's going to help me build the circle. So the h is the x in the center. So x minus 0 is the same as just plain x, and square it. Y minus 0, which is for the y value over here, is the same as just plain y, and square it. And then 14 squared is 16. So I can write x squared plus y squared equals 16. And I can do that because the circle is centered on the origin, or the 0, 0 mark. Okay? So then they asked us to graph it, and they gave us the equation. Okay, so let me write under here again. X minus h squared plus y minus, and there's a plus here, so it must be, well, let's just do this. Minus k squared equals r squared. What do I know so far? Easy peasy, r has to be 2 because r squared is 4. Okay, this matches up. Okay, sorry, I had to step away for a second. Okay, so where were we? Okay, so hopefully you're clear on how I got the radius to be 2. I just knew that r squared had to be 4. So this is what I basically did. If r squared equals 4, take the square root of both sides, and you get r equals plus and minus 2. But the radius can only be positive, therefore r equals 2 is my answer. Okay, let's do some more matching. I can see that the h matches perfectly because they're both subtractions, so the h has to be 3. So that's good. Now look at the y. So I'm going to bring this down here. This says y minus 2 squared. The form I'm following is y minus k squared. So how can I make sense of this? What if I wrote the first one as y minus a minus 2 squared? That does it. That lets me recognize that that k must have been a negative 2. So what do I have now? What is my hk? My hk is the center of the circle. And I know my center is 3, negative 2. So on our grid, I go across to 3 and down to negative 2, and that is my center. If my radius is 2, that means that this is a point on my circle. 1, 2, that's a point on my circle. 1, 2, that's a point. 1, 2, that's a point. So I'm going to try to draw that circle. Okay, and that worked. There you are. You have your center at 3, negative 2. And you have, I'll put the radius here, a radius of 2. All right, and that completes our review packet.